Bom dia, SaoPaolo. I'm really stoked to have you on board and really happy to be the video maker for your first meetup. Today I'm gonna give you a brief introduction into Polkadot in general, all of the concepts. It's gonna take a while to get through them all because it's a pretty complicated system. And throughout the video I'm going to insert some little breaks during which you can kind of catch your breath, maybe get some coffee. I mean, the whole video is not going to be too long, but I want you to be able to think about the concepts during these breaks, discuss them maybe, put them on paper as in form of questions, and then maybe because your meetup is happening at the same time that I'm landing from a flight from the Web3 Foundation retreat, I'm landing in Croatia. Just as you guys will be watching this video, I'm kind of hoping that I'm gonna arrive back in the office at the same time as you guys finish watching it. So my ideal scenario is being able to connect into your call if you're gonna have some kind of stream available, a meetup or something, and answer the questions that you've gathered live, so that we can also discuss while your meetup is still going on. I think that'd be pretty great, and I think that would clarify a lot of the things that you might maybe misunderstand or need clarifying after this presentation, though hopefully not too many. So let's get started. I'm not going to assume that you know anything about Polkadot, but I am going to assume that you're familiar with blockchain basics. So basically, what is the blockchain, how does it work, what its problems are, and why Polkadot is being developed in a way. And the rest I'm going to try and clarify to the best of my ability. So let's begin. Alright, so this is me, I'm Bruno, I'm a technical educator at the Web3 Foundation, and you can always reach me at any of these contact information resources. So I'm on Twitter, you can find me via email, just contact me about anything at all, and you can visit my personal site if you want. With that out of the way, I will leave this contact information with your meetup organizers, so you can also just contact me through them. So, as an overview, Polkadot is a heterogeneous multi-chain that connects and secures blockchains with pooled security and interoperability. That sounds like a lot of complicated and, quite frankly, silly words that you might expect to see in some kind of an ICO white paper in 2017. And indeed, these are words that just try to sound very smart. What this means is that Polkadot is just the internet of blockchains. So it's one system that connects multiple blockchains of different purposes. These individual blockchains can have their own logic, they don't have to be identical, and they can all connect to one system to share its security, so that the weakest chain in the whole system isn't weakening the entire system as a whole. For example, that's going on in Cosmos. So why Polkadot? Well, Polkadot aims to be a foundation for other protocols. So we aim for interoperability, which makes interaction between existing blockchains easier because the blockchains can actually talk to each other. We aim for pooled security, so that like I said, the weakest chain is not weakening the entire system. We aim for heterogeneous chains, so that they can be application specific. So one chain can deal with one type of transactions, another chain can deal with a completely different type of transactions. And there's a kind of thought through governance, or in other words, it's governance that we've thought a lot about. So there's on-chain governance, and people can actually vote for things to change about this protocol on the protocol itself. It's kind of like changing the engine of a car while it's still driving. And we've actually tested this successfully in the Kusama network, which I'll mention at the end of this video. And this is kind of what the Polkadot ecosystem looks like. This is a wonderful visualization by our designer Iggy, and while this might look complicated and very confusing, at the end of this video I hope that you will understand every part of this system, because it's actually not that complicated. It just represents the peak of Polkadot. It represents the final stage of Polkadot. So Polkadot is actually, if you look at the gray circle in the middle, that is our relay chain, the main chain that's securing the whole system. The purple lines are the validators in the system who are doing this securing, and the pink boxes are these parachains or parallel chains that connect to the master system through parachain slots. That's these black little boxes on the gray circle. And the outer purple circles are collators. And we're going to explain each of these elements separately, but I just wanted to give you a brief overview of what on this image represents which part. The lines inside the circle are the communication channels between these parachains. So these are chains talking to one another and relaying messages. So let's dive in a little deeper. So Polkadot's architecture consists of this. This is actually a simplified version of the diagram that you just saw. And Polkadot's architecture actually rests on this concept of the relay chain. And this is similar to, if you're familiar with Ethereum 2.0, it's similar to the beacon chain in Ethereum. So we have this master relay chain in the middle that has some parachain slots. And parachains, or parallelized chains, are connecting to these slots through their validators. These validators are members of the system who have put down some stake on the master chain to be able to participate in this system. And the stake just basically guarantees that they'll behave, because if they misbehave, their stake gets taken away. So basically they promise that they'll be good with money. And the validators are shuffled between these parachains. So not one set of validators isn't always responsible for the same parachain, so they get shuffled. So that there's no way to bribe the validators of a specific chain to, for example, censor it or something like that. So we have these parachains that are connecting to the master chain, and that's the basis of the system, and the elements are built on those concepts. So we have the relay chain, that's the gray circle, which secures the parachains, and it secures them by keeping that stake from the validators. So by keeping a lot of money locked up, it makes sure it's secure, because there's a lot to lose, and relays messages between them in some cases. We'll explain that later. Validators are staked full nodes of the relay chain. So these are programs that are reading and writing to the relay chain, to the master chain, and they are also responsible for verifying and adding blocks to this chain, and for verifying that the parachains are doing a good job with their state transition function. Now, what's a state transition function? That is the process of moving from one state to another state. If you imagine a computer game and you have saved a point in the game, that is your current vision of the world, or in other words, that is the current vision of your avatar's vision of the world. If you keep playing a little bit and then you save again, you have a new save game that has a different view of the world based on your actions in between the last save point and the one you just made. This is a state transition. So you have transition state of your save game from the past save game to the new save game. And the variables that have changed in between them belong to this state transition. So this state has transitioned to a new state. This is a simplified way of looking at state transition functions, but in essence, this is kind of the basis of the Polkadot system, where there's a specific rule that parachains have to respect in regards to their state transition, and if they respect it, they can join the system. That rule is, if you have made a state transition, produce proof that that state transition is valid, and let the validators also execute that state transition so that it matches that proof. In other words, give us the proof that the state transition is valid and let us reproduce it. And if that's possible, the validators will say, fine, you will be included in the relay chain and you will share our security. This also means that the parachains don't actually have to be chains themselves. As long as the application, let's call it an application, not a blockchain, as long as the application that is connected to Polkadot has the state transition function which matches that requirement, so give us the proof and let us prove it ourselves that those things match, it can be connected to Polkadot. And that might as well be a computer game with save games. It could be a blockchain. It could be a DAG, a different kind of blockchain. It can be anything you want, as long as it respects that state transition rule, that it's provable by the validators. That's it. This also means that it can be a private blockchain. So a parachain can be a private blockchain from an enterprise or anything else. As long as it can produce proof that the state transition was valid, it doesn't need to share the data. It just needs to share the hashes of the data and make sure that the state transition is valid. If the validators can make sure that it is indeed valid, that chain qualifies to join the Polkadot network. And that's the real power of the Polkadot network, is that these individual application-specific, very specific blockchains or non-blockchains can actually join the network and share the security of the entire system and also communicate with each other. That means that you can, like right now on a blockchain like Bitcoin or Ethereum, if I buy a cup of coffee somewhere, that transaction of coffee is going to be validated by absolutely everyone on the chain. Even the, I don't know, military that uses it to log its one nuke per week or something. But on Polkadot, there might be a parachain that's specialized for coffee transactions, and it does a lot of those really fast, really often, really well. And it's like this coffee chain, and all of the coffee transactions in the world can happen on this coffee chain because it's optimized for coffee transactions. So all of that can happen on that chain while the rest of the network is doing its own thing. So other chains are doing their own thing, the relay chain is doing its own thing. And my coffee transaction is not bothering the rest of the system. And this is the way that we can really scale the system. If we separate the transactions by their context, rather than just divide them up randomly into shards like it's being done in Ethereum, this means that we can have highly specialized blockchains doing highly specialized things, but at the same level of security as the entire system. And that's the real power there. So each parachain can have a unique implementation with its own runtime logic is the key takeaway here. There are also parathreads. So in order to become a parachain in the Polkadot system, you need to claim a slot. And the slot is this white hole in the relay chain. So there's going to be a limited number of these parachain slots, and you will be obtaining them through an auction system. So if you want to become a parachain, you actually have to win an auction. The auction is a candle auction. That means that when you're bidding on a parachain slot with others who are also bidding on it, you don't know when the auction will end. There is a window during which you can bid, but the end of that window doesn't mean the end of the auction. Instead, when that window expires, a random number will be selected from the blockchain, and that random number will decide when that auction ended in the past. So the entire bidding period might last like 200 blocks, but then the random roll will decide, hey, this auction ended 70 blocks ago. And actually, the person who had the highest bid in block 130, that's the winner. So why do we do this? Because if we use this approach to auctions, this means that people will be incentivized to bid their maximum amount early. So it's not going to look like small increases until the end and then a race at the last minute to be the last one to submit a bid. This would not work in blockchain because people could actually analyze transactions and just put in more of a tip for the validators to include that transaction and so on. It would lead to just basically transaction gaming rather than actual auctioneering. So we don't want that. And the candle auction solves this problem effectively. And so once you win this auction, and your auction will let you lease that slot from anywhere from 6 months to 2 years, so that's the duration of the parachain slot, you own that slot. And you can put your parachain in it. You can connect your parachain to it. Now, there's going to be a limited number of these slots. So at the beginning, we're aiming for something like 20-ish, and then later on, we're going to scale that up to 100, and then later on, as the number of validators increases, we can increase the number of parachain slots. And as one of those numbers increases, we can increase the other one. We hope to keep raising that over the years. But still, we expect there to be more demand than we can raise this limit. So rather than prevent a lot of people from joining our ecosystem through a lack of parachain slots, and we don't want that, we have instead decided to implement another functionality which is called a parathread. And a parathread is actually a parachain slot shared by multiple parachains. So like you see in this image here, this little dashed line indicates this parathread pool. And these gray boxes inside, they are actually parachains. But, well, we call them parathreads in this case. And this entire box shares one set of validators processing this entire box. So it's exactly the same as all of these others, only we have a slot shared by multiple parachains. And what good does that do? Well, the difference in logic is none. So the parathreads are actually identical logically to parachains, and they share the same security. The difference is economic. In parachains, when you win your auction and when you join the system with a parachain slot, you basically are guaranteed free transactions to be included in the relay chain for as long as you have that slot. You don't have to pay for transactions for the validators to include your proof in the relay chain. And since this happens every 6 seconds, to follow the slot time, the block production time of the entire Polkadot system, then that comes down to a lot of transactions, you know. Oh yeah, I forgot to mention that in the auction, you don't actually, like, while you do pay with dots, and that's a native token of the Polkadot network, you don't lose those dots. After your lease expires on the parachain slot, you get the dots back. So you might be wondering, like, how is that paying then? Well, because for the duration of that lockup, you were not doing anything else with those dots. You couldn't sell them if the price rose, you couldn't use them in staking, and you couldn't use them as in DeFi. You couldn't use them to loan them out, to get interest on them, and so on. So you were actually spending money by not earning it on those dots. And this is kind of the expense that you pay. So in parathreads, you don't actually have the auction model at all. Some slots will be reserved as parathread slots, and there's no need to get auctions for them. However, when a parathread needs to write a block, it needs to send that information to the validators, like we mentioned before, like any other parachain. But it needs to do so along with a lot of other parathreads in that same pool. And what happens then is an auction takes place. And this is a separate type of auction where each of these parathreads is competing to be included by the validators. And they are competing by bidding on their inclusion in the blocks. So basically, if the first one needs to include a transaction in the relay chain, and the third one needs to include a transaction in the relay chain, the one has to outbid the other in order to be included in the relay chain. So this one will bid 0.001 dot, and this one will bid 0.002 dot. And then this one can bid 0.003. This all happens automatically up to a limit that you define. And then the one who wins will get included. The other one who loses can get included in the next slot, but there's a chance that somebody else will have to write in that next slot then, and they might be willing to pay more, and so on. So it's a constant race on basically writing when you need to write, and racing others if they need to write at the same time. The payment that you do for these auctions is non-refundable. So this is actually a transaction cost. So parathreads are, in fact, they don't have to submit the auction every 6 seconds like the block time of the relay chain, but when they do, they need to do this auction. So the major benefit of parathreads is that they are essentially parachains that are write rarely, read often. For example, imagine a parachain that deals with identity, or maybe it deals with copyright, or maybe it deals with I don't know what, like a game that very rarely has any move, or maybe even a DeFi parathread, because in DeFi, in decentralized finance, people usually deposit some money and then just monitor their account. They don't do the actions anymore on their account. They just wait for the interest to come in. So that's a write seldom, read often chain. And since parathreads don't have to submit a transaction every 6 seconds, they can actually submit only once per however often they want. 6 hours, 1 day, 1 week, doesn't matter. And the only, let's say, risk there is that the parathread is only as secure as the distance from the last moment it sent its transaction to the relay chain. Why is that? Because when you send your transaction to the relay chain, when you're validated by the relay chain, then you're finalized. Your blocks are finalized. And that means that the data on your parachain cannot be reverted. It can't be turned back. So you can't really lose your progress. And if you do that only once every 6 hours, that means you have a 5 hour and 59 minutes window in which, if someone attacks your chain, which is not a real possibility, but it could happen, if someone attacks your chain, they could potentially revert the last 5 and something hours of work on that chain. So that's a little bit of a risk there, and that's why the parathreads will still want to include their transactions as often as reasonably possible. But again, if they don't have writes on their end that often, so for example, if I have a copyright chain which has on average 2 transactions per 6 hours, then it's totally fine if I do 1 transaction to the relay chain every 4 hours. That's reasonably safe, and it's going to be very, very cheap. So I don't have to do all of these transactions all the time. All other aspects of this parathread model are the same as the parachain model. It's just that here you don't have free transactions to the relay chain, but with parathreads you do. But with parachains you do. And it's much cheaper to be a parathread because there is no large deposit. You have to make some deposit to get a parathread slot. So to join this pool, you have to make some deposit because we don't want to encourage spammers. We don't want to fill up the slots with nonsense. But it's going to be much, much cheaper than with a parachain and much, much more approachable. So just average projects can do it. For example, CryptoKitties, if you're familiar with the collectible game on Ethereum, they wouldn't want a parachain because that would be too expensive for them at this point, and they no longer have the demand for the transaction throughput that they used to have. But they would do rather well as a parathread because their players only once in a while submit some actions to the system, and they can then finalize those actions with the relay chain every few hours. That will work just fine for them. So these are parathreads, and this is one of the most anticipated models of joining the Polkadot ecosystem. And the last element that I haven't mentioned are collators. So in this big diagram, these little dots on the outside. So now that you know, what most of these elements are. The gray circle is the relay chain. The purple lines are validators. The pink boxes are the parachains, and the purple circles on the outside are collators. So let's explain those now. So collators bundle or collate transactions on the parachain. They monitor into blocks. They send a proof of this block to validators. What does this all mean? Here's what this means. So let's explain on this simple example. Collators of the A chain collect, so they execute the state transition function of the A chain. So chain A has some transactions. It gets some more transactions, and then its state changes. So the state of the entire chain has changed based on these transactions. These transactions are executed by the collators. So the collators are the full nodes of the parachain. They do the work that, for example, right now, the Ethereum or Bitcoin nodes are doing. So they process these transactions. Once they are done, they use that calculation to generate a proof that proves that they did this processing. And then they send that proof to the validators. The validators get that proof, and they get the hash of the last state of A chain, of chain A, and the hash of the new state of chain A. They use the proof and the hashes to generate their own proof that this state transition is indeed valid. And if it is valid, then they include the proof in the relay chain. So the collators are the nodes doing the writing. They are producing the blocks and sending them to the validators to include in the relay chain. These are the ones that you need to build as a community when you're building your parachain or parathread. Basically, when you're creating your parachain or parathread, you will have very little difficulty creating the chain itself. We have a lot of software that can help with that. What you have the most problems with is getting people on board to run your chain, so finding those collators. You have to get people interested, you have to think of a crypto economic incentive to basically incentivize them to actually run your chain, and this is all up to you. So you have to design those methods, you have to build those into your chain. This is something that's outside the scope of the Polkadot ecosystem design, because that's completely up to the designer. In a private blockchain like an enterprise, or like, for example, a cartel like airlines, the airline cartel will have a proof of authority blockchain probably. So they will know who is the member of the blockchain, and they will vote in new members. They will not, for example, let anybody else join, but they will know who's inside. And they will not expect rewards from the blockchain, because it is in their interest to work together and keep this system alive, because cartels by definition have members that don't like or trust each other, but that have to work together to keep the prices high and so on. So it doesn't matter what type of collator you implement, it's completely up to you. So you will decide the economic incentive of the collators. And you might have noticed that the word fisherman has appeared in two places. So validators can also be fishermen, and the collators can be fishermen. Now, a fisherman is a monitor of the entire network or a part of the network who looks out for illegal behavior. So if a validator signs a block that they're not supposed to be signing, or if a collator submits wrong proof, or if something else illegal happens, a fisherman can notice this and report it to the relay chain. And the fisherman will get rewarded for accurate reporting and punished for wrong reporting. So a fisherman also puts in a little bit of a stake, some dots into the system, guaranteeing that they're going to do a good job of ratting out the evildoers. And when you find someone who's doing something wrong, they get punished or slashed. Their money gets taken away. Their stake in the system gets taken away and put into the chain treasury. And from that treasury, other stuff can be funded. I'll explain that a little later. But essentially, these fishermen are cops of the system. They're monitoring this. And there's a special mode of running the collator or the validator. It's just an option that you activate. It will take much more CPU power. Your computer will have to be much more powerful to monitor the entire network for ill behavior, but it can make you money. And one other thing that I forgot to mention is bridges. So this, for example, is a bridge. A bridge is just a parachain that is connected to an external blockchain, like Ethereum, like Bitcoin, and so on. And bridges allow us to connect non-Polkadot friendly blockchains to Polkadot by making that bridge, making that connection. And in the case of other blockchains, the collators will then basically translate the state transition function of the other blockchain that is not compatible with the relay chain's requirement. They will translate it into one that is compatible with it, regenerate that same transition proof on their own way so that validators can understand it, submit it to the validators, and then the validators continue processing it just like on a regular parachain. So this is how we can connect other blockchains into the system as well. This is how we will bring Ethereum into Polkadot and Bitcoin into Polkadot and all of these other chains into Polkadot. So this is the true internet of blockchains in a way. Another method of getting, so since there will be few of these parachain slots, and we really want there to be more so that people can join, apart from parathreads, another method of scaling these slots is by using nested relay chains. And nested relay chains are a thing coming in Polkadot version 2 later on, which will basically look like this. So this lower part here, that's a chain that is also a relay chain connected to a parachain slot. And then that relay chain can have in one of its slots another relay chain, and so on and so forth. So you can go deep, like a nested chain and a nested chain and a nested chain, and we can have a lot of chains nested within one another with a lot of slots, like being, like flowering out. That's it for the first section. Now I encourage you to discuss these things among yourselves and come to some agreement on questions and answer things that you can answer, maybe make some assumptions on what's right, what's wrong, what might be the problem in any of these cases. Put those to paper and ask me when I arrive. If I arrive, I hope I will. If not, I do hope that we will meet on another meetup where I can call in maybe through a meetup and answer your questions. Try to discuss it, try to come to some consensus. Let's take a little break here and then we'll continue. All right, we're back. So I mentioned staking before. And staking, as you might know, is putting some money into the system as a guarantee that you're going to do a good job of processing the transactions. And the proof of stake mechanism that Polkadot uses is called nominated proof of stake. So it's kind of similar to delegated proof of stake, if you're familiar with it. If not, I'll explain it. So in a pure proof of stake system, like for example on Ethereum, You put down some stake and you become a validator, and then you will randomly be selected to process a block. If it's your turn to process a block and you do it successfully, then you get a reward from the system. In Ethereum, that requires 32 Ether, and you basically join the system, and there's no way to get more. Like, you can't really stake with 40 Ether or something like that. You can only do it in increments of 32, and if you have another 32 Ether, you have to run a new validator. So you can't run one validator with 64 or something. This is so that Ethereum can have many validators. With delegated proof of stake, the idea is that there's a smaller number of validators who are more powerful machines, and these validators are processing the transactions. But then these delegates, so delegates are people who own the token of the network, they can vouch for some of the validators, and by vouching for some of the validators, they increase their stake without actually sending them their tokens. So it's kind of like, I have my own 100 tokens staked, and then my friend vouches for me, delegates to me 20 tokens. It will be as if I have 120 tokens, but actually he will keep his 20 and I will still have my 100. It's not like he sends them to me. They just count as mine in the staking system. And then in the delegated proof of stake system, if I do something wrong, I'm going to get punished. But I'm going to lose my 100 and my friend is not going to lose anything. So the delegates are just incentivized to just randomly click on different validators and just leave their money in there, because nothing bad can happen to them. And the validators, on the other hand, they must have their own stake. So they must put down some of their own stake in order to become validators, because otherwise they would have no real punishment. There would be no real punishment for them. If they cannot lose anything, if they don't have to put down their own stake, then they can behave as badly as they want, because there's nothing to lose and the delegates can't be punished. And that can be a very ineffective system, which fosters elitism and creates cartels. Like for example, EOS has a big problem, and as well as Lisk has big problems with cartels of validators. So Polkadot went with nominated proof of stake. In nominated proof of stake, you can validate with 0 of your own stake, because the nominators, which is the alternative to delegators here, they also can nominate validators. And nominators are just people who have the DOT token, which is the Polkadot network token. The nominators can nominate validators, and they also keep their stake, they don't send it. But nominators in the system can be punished along with validators. So this is why validators can become validators with 0 of their own stake, because there is much to lose for the nominators if they back the wrong validator. And now the way that works is, a validator has now a certain amount of stake behind them, backing them. And the top X validators, the top number of validators in the system buy stake, and that X, how many validators, that varies depending on network conditions and so on. Right now it's 150. So the top 150 validators will be selected to create blocks. And if one of them misbehaves, that validator will be punished. That depending on the type of misbehavior, the percentage of punishment will vary. Sometimes they'll lose 1% of their stake, sometimes they'll lose all of it, and so on. But what matters is that they will be punished, and also the nominators that have supported them will be punished. So they will lose some money. Why is this good? Because it helps nominators pick the validators with the highest reputation. But there's also another mechanic in here. And that's that the more stake a validator has behind them, the more dangerous it is to back them, because rewards are not proportional to the amount of stake you have. If in that 150 top validators, the first one has 1 million dots and the second one has just 10 dots, they will both get the same reward for block production. So even though this guy has much more dots, much more stake behind him, he will not get a bigger reward for processing a block than the second one. And that's an important distinction to make. But while the reward is not proportional to the block reward, the punishment, the punished amount is proportional. And that means that the one with more money behind them will suffer a bigger punishment if they do something wrong than the one with less money behind them. And this basically incentivizes nominators to support the less popular validators. Because if they support one with a lot of dots, that means they can lose more, because the percentage of loss will be much greater. But if they support a less popular one, then that one will just get equalized with all the others in the network. So the idea is that after a while, this is all going to get equalized in a way that all the top 150 validators will have the same stake behind them. And that way there's no one whale controlling everything. There's another equalization method called fragments method, but I'm not going to go through that. It's a little complicated, and it's not ultimately very important here. So that's how our nominated proof of stake works. That means that you can, so people often ask, how much money do I need to become a validator? 0. You can become a validator with 0 of your own stake if you're a good politician and can talk people into supporting you. So this is a kind of a lobbying game where you have to find supporters who will nominate you to be a validator. And that's an interesting game theoretic problem here. Another concept that we need to go through is cross-chain message passing. So how do these chains in the system actually communicate? And we have this protocol called XCMP, so cross-chain message passing, which guarantees the delivery of messages between parachains and parathreads. The messages work like regular messages, regular commands that you send on a machine, but these don't get saved on the relay chain. So for example, every chain has an inbox and an outbox. And when a chain needs to send a message to another chain, it goes into the outbox of the original chain. Then when a block is processed, that message is put into the inbox of the other chain. And each block, this processing happens, and the queues have to be emptied completely, otherwise the block won't be valid. So this messaging is happening all the time between them, but the messages are not stored on chain, only the hashes of the queue, so that the system can know if the queue was empty or full and so on. So these messages are getting processed that way, but the messages themselves are stored as fragments on in between the validators and collators and so on of the network. It's a little bit convoluted, but suffice it to say that this system allows you to send a message from one chain to the other in the space of one block. Now, but what does a message actually mean, right? Like, if I send a message from one chain to another chain that says reduce user X's balance by 100 tokens, how can I be sure that the other chain knows what user is, what token is, what balance is, and what 100 is? You know, unless I've built both chains, then I know, of course. But if I didn't, how can I be absolutely sure that users aren't apples in the other chain and 100 isn't actually 100,000? Like, I can't know that. And to solve that problem of basically trusting the other chain to interpret our message properly, we've developed Spree. And this is a shared protected runtime execution enclave. You don't have to remember what it stands for. Sprees are kind of like a standard library for parachains. You know, like when you're programming, you have a standard library of a language. Like in Python, if you want to manipulate strings, you will import the standard library for manipulating strings, and then you have access to it. And every program that wants to inherit from the functionality of your program will do the same thing so that they can also access that functionality. It's kind of like that. So Sprees are little bits of logic on the relay chain, on the master chain. And when you have these bits of logic, the chains that connect to the master chain will kind of check box what they are subscribing to, which of those little blobs of logic. So they'll say, I want balances, I want governance, I want something else, you know, and I want smart contracts, you know, stuff like that. And they're just going to check things off, and anybody can at any time see what Spree modules a chain has picked. And then if I have a chain, if my chain has also picked balances, and my target chain to which I'm sending a message also has balances, that means if I send a message, reduce user X's balance by 100, that target chain cannot misunderstand my message, because my message is going through the Spree, which is kind of the translation layer here, and the other chain must respect whatever is said in the Spree about the balances, because the message I'm sending is coming through the balances Spree. And this ensures that the chains can communicate without human intervention, without having to check on the application level if the transaction has resulted in the outcome that we wanted, because we know it will. Through spree, it must result in whatever is written in the spree. So this is how the chains reliably communicate. This is the true machine-to-machine communication in this case, which can be fully automated and fully trustless. So this is the spree module, and in tandem with XCMP, we have now created the universe of blockchain communication. And with bridges that I mentioned earlier, so a bridge to Bitcoin, a bridge to Ethereum, this can now serve to trustlessly pass Bitcoin into Ethereum. Like right now, you have a token on Ethereum called wrapped Bitcoin, which is basically created when a trusted institution takes Bitcoin from someone and then creates the wrapped Bitcoin token on Ethereum. And then you kind of have Bitcoin on Ethereum. But you have to trust that institution to do that. With cross-chain message passing and spree, that is no longer necessary. You will be able to directly pass Bitcoin into Ethereum because the bridges can communicate this. So the bridges are doing this work. And the message is translated through sprees so that it can reach from one chain to the other chain. And that's extremely powerful. That's freeing up this internet of blockchains. This is the end of the second section. They're only going to get shorter from now. So brainstorm, discuss, get some questions in there, and shoot them at me later on when I tune in to your meetup. And we're back. All right, governance. So Polkadot has this controversial feature called on-chain governance that a lot of people say can't ever work. We have so far proven otherwise, but we are absolutely willing to be proven wrong. We want to run this experiment and we want to see what happens. So our governance is the process of voting on the chain itself about the changes of the chain itself. This allows us to tweak the parameters and change the logic while it's still running. And our governance is kind of led by these 5 main features, main tenets. So the ability to make good decisions, we want fair representation, and we want the ability to decide things despite voter apathy. So if people don't come in to vote, we want to have a reasonably fair decision. Coherence, so we want to be able to upgrade the chain through governance so that we don't have to do forks. We want to preserve decentralized qualities by not privileging any party over another. And we want to have security so that we are safe against bugs. And of course we want to scale things. So we want to be able to have governance whether there's 100 people voting or 100 million people voting. We don't care. We want to be effective no matter what. So the governance system of Polkadot is tricameral. This means it has 3 chambers. And the 3 chambers are dot holders. So that's anybody, any owner of dot tokens. They are the first chamber. They are the main kind of body of the voters. The council is a specially elected set of people who started with 6 seats and then every 2 weeks increases by 1 until it reaches 24. And then the oldest one gets kicked out and the new one gets voted in and so on. Election seats last for 1 year. So once you're voted in, you're in for a year, unless somebody votes you out by emergency in between. And the council is are members who have the best interest of the network at heart. So they will be people who understand how the network works, who want the best for the network, who want to have a say in its governance and so on. These will generally be your technically capable and very enthusiastic people who would, in Ethereum's case, be very loud voices on Twitter, but in this case they would be very effective actors in the governance process. The council members are elected by the dot holders, and this happens by whoever wants to be on the council, they need to kind of raise their hand by submitting a transaction into the system, and they will be then listed as the council candidate. Then dot holders can vote for them. They don't lose the dots or anything, they just vote with the number of their dots, and their dots get locked up for a certain period of time when they vote, so that they can't really send them to anybody else and say, you vote, you vote. So the dot holders will vote the council members in, and they will just get added into the seats in order of number of votes. And these are the main two bodies. Now, these two bodies can submit proposals, also called referenda, into the governance system, which would influence the system in some way. This influence can be anything from changing a parameter, like changing the number of validators in the system, to completely replacing the logic of the blockchain. So, for example, you can activate or deactivate a certain module in the code, like somebody might suggest to turn off all transfers in the whole blockchain. Why? Because maybe there was a huge hack, and in 5 hours the hacker will have access to 17 million DOT. And by making a vote to freeze all transfers on the entire chain, the stakeholders can actually pause the condition of the chain and discuss what to do about the hacker before the hacker gets their money. This would have come in handy at the DAO hack in Ethereum, where a lot of money was lost and a fork of Ethereum Classic was created because the agreement couldn't be reached on what to do. So these proposals can really be literally anything. Now, there is a difference between the types of proposals being made. Actually, let's first talk about the third level of the governance, and that's the technical committee. So any team that is developing a Polkadot client, that is the software that is running the Polkadot network, is qualified to have a seat on the technical committee. There are several teams developing the runtime, but only one has shipped something so far. So the technical committee now consists of two teams: the Web3 Foundation, which has developed the Polkadot protocol, and Parity, which has developed the Polkadot client. And they don't have any special ability except the ability to fast track a proposal. So they have the ability to speed up a proposal. Now, a proposal typically takes 28 days to be voted on, and then another 30 days or so to be enacted, so that it gets implemented. And waiting 2 months for something to happen is too long in a lot of cases where it's urgent. And technical committee therefore has this power where if they vote to speed up a proposal and most of the council agrees with that decision to speed up the proposal, that proposal will happen much sooner and the voting process will be much shorter. So instead of 2 months, it might happen in like 3 days or 3 hours. And that proposal can then urgently be effective, and this is very useful for like critical fixes and so on. So that's the technical committee. Now, when anybody raises a proposal, when anybody suggests any change to the protocol, it goes up to a vote. But the council can indicate their support of that proposal. And if the council doesn't support it with a majority, so if only a few of them support it or none at all, then the proposal will be biased towards failing, which means that it needs a super majority of yes votes to pass. This is a spam prevention method. So if a lot of DOT holders just decide one day to put in a lot of spam proposals into the system and break the system that way, because a lot of spam proposals would pass because nobody has time to read them all, this would not work. Because if the council doesn't support them all, then all of these proposals need to be backed by more than 75% of yes votes. And if you vote for one, that means you can't vote for another with those same votes. So there's no way to attack the system that way. If the council supports a motion with a majority, so more than 50% of the council, then that proposal is going to be a simple majority. So it needs a 51% to pass. And if all of the council supports a motion, that means that that proposal will be biased towards passing, which means that it needs a supermajority of no votes to fail. This is so that the council can avoid the voter apathy. So if a lot of people don't show up to vote, but the council thinks an idea is good, they can just set it up so that it automatically passes after a while, even if very few people show up. And this is kind of the governance model here. So you have a seat of experts that decide on things, and you have a huge body of voters which who have the possibility to vote on every proposal in the system. They also have a way to increase their voting power by locking their tokens for a longer period of time. If you vote for, if you just issue a regular vote, so 1.1 vote, then you will lock your tokens for like a month. But if you lock them up for 2 months, you get 2 votes, and if you double that, you will get 3 votes, and so on. So you can lock your tokens for a maximum of 2.5 years for a maximum of 6 votes per dot, and this can like make you much more powerful than a whale who is willing to vote only with 1 vote. That's it for the governance. Please discuss, think about some attack methods, think about some problems that might arise, think about some issues that you see with this, and I would really like there to be some really challenging questions. So try and think up some problems that might happen in this case, if you can. Let's discuss it when I tune in. Alright, almost done. Moving on. Now, we have discussed the Polkadot ecosystem as a whole. That's how it works. Those are its systems. I didn't go into too many details about every little aspect because there's so much more to cover. But I encourage you to ask me about anything else that you're interested in, and I will go into as much depth as you want. Right now, let's briefly discuss Substrate, because I think that's an important part of this whole ecosystem. Polkadot is being developed right now. The actual software is being developed by Parity, and Parity is a technology company, development company from Berlin, which is co-founded by Gavin Wood, who also is the founder of the Web3 Foundation. Now, Parity is developing the software, but they've been a blockchain development shop for a long time, and they've developed blockchains multiple times, and they started wondering, like, why are we doing this over and over again? We're reinventing the wheel with the consensus and with the rules and with the storage and with everything. Like, every time we're building this anew. So they decided, let's build a framework that lets us get started quickly, and they called that framework Substrate. Substrate is basically a template for a blockchain into which you can plug different modules. This is what it looks like. So you have a Substrate template, you just download that off of the internet, and then you decide, I want my blockchain to have governance, and I also want it to have balances for coins. And then you just say, okay, pull this module and to pull this module. And they just get connected to your Substrate module, and once you click build to create your node, to create your software, that's it. You end up with one software that you can send to your friends, family, coworkers, whoever else. Once they run it, they're connected to your blockchain. So Substrate is a kickstart framework for creating your own blockchain. Not Polkadot chain, not Parachain, any blockchain. So Substrate is kind of Polkadot independent, but Polkadot itself is being built with Substrate. So they are building Substrate in a way that they are dog-fooding it. So they are using it for all of the mission-critical work, and when they see something wrong, they fix Substrate. So you can be sure that it's a very shippable, very professional tool. What's more, with Substrate you will get this additional plugin that's called Cumulus, and Cumulus will let you easily boot up a chain that is connectable to Polkadot. So Substrate chains on their own are not directly connectable to Polkadot, but Cumulus adds that missing layer for the state transition verification that lets you connect it to Polkadot. And actually that was just presented last week at the Sub-Zero conference in Berlin. So Cumulus is maturing as a software and will be available early next year. But in the meanwhile, you can build your own blockchain with Substrate that doesn't have anything to do with Polkadot. Just run your own blockchain, use it for anything else, customize it however much you want, and play around with it. We actually have a workshop online that teaches you how to build a Substrate chain for CryptoKitties. So you build your CryptoKitties clone on Substrate as a special chain. Check it out. So if you're developer minded and if you want to build your own chains and maybe get a head start on building parachains by knowing about Substrate and using it, I encourage you to visit substrate.dev, which is the developer portal for Substrate and all of the things that deal with developing things on it. And you will find a lot of resources there. You will also find a lot of contact information there, like the Riot channel for discussing Substrate technical issues. Even Gavin Wood himself answers questions there often. You will find tutorials and interactive videos and so on. So please check it out and join us in the Substrate development world. Now, I'm going to skip over this Q&A part because I don't think you have that much to discuss on Substrate. If you do, please just add it to the other questions. Let's speed ahead and move on into the next part. Kusama. Kusama needs to be mentioned because we are basically running it right now, and it's a proof of concept that Polkadot actually works. So Kusama is Polkadot's canary network, which means that it's kind of like a test network, but with real value involved. So in a test network, you can painlessly restart it and destroy it, and nobody's going to get very upset because the tokens don't actually have any real value. On Kusama, we intend to keep it running indefinitely. So as long as Polkadot will be alive, Kusama will be alive. Only on Kusama, things happen much faster, and there's things aren't that careful. So we want to expect chaos, and we want to encourage chaos, and we want people to experiment with breaking the system. And if you manage to hack your way through the system and steal somebody's KSM, and KSM is like the DOT token but for Kusama, that's good. You can keep them. We have learned that our system doesn't work for preventing you in that, and we will be wiser. If we manage to stop you, then that's also good. We will learn that our system works. So please go and expect chaos. Kusama has actually just recently launched a full version of its governance model, and we have actually issued already a few upgrades on chain through voting. For example, we have activated before a week and a half ago, from the moment you're watching this video, you couldn't transfer KSM tokens from one address to another. We had to enable that module on chain by changing the logic of the chain through a vote, and we did that, and it worked. We also did a lot of other stuff, a lot of interesting stuff in the governance, and we've played around with a lot of the aspects of Kusama. And soon enough, we'll be activating the parachain slots so that you can connect parachains to it and really experiment with the full power of the Polkadot network in a early alpha form on this Kusama network. So please join. More information is available at kusama.network. Join us in exploring it, and let's break it together. Now, if you have any questions about Kusama or Substrate, please put them here. Please take the opportunity to kind of write them down and prepare them. But right now, I'm going to rush ahead to grants. This is the final part, where I just want to mention that the Web3 Foundation is giving out a lot of grants. We are looking for teams building tools, building systems, building alternative Polkadot runtime implementations, so nodes. Anything you can think of, we are giving grants for, as long as it forwards the health of the ecosystem. So if it's a Web3 project that touches on Polkadot in some way, please apply. We would be happy to discuss it with you and potentially fund your project so that you can build something awesome for other people to enjoy. We are currently funding over 40 plus projects in 19 plus countries across the world, so we are definitely not limited to any geographical location, and we are not stingy with our money. Sorry. There's also the Polkadot, and this is for the people who aren't really technical or too technical or don't want to build something but want to educate, build community, or create smaller tools. If you go to any of these links, you will learn more, but essentially it's a DAO in which you can submit a grant request for a kind of this meta work. Like if you're organizing a meetup you can basically submit a kind of expense grant where you want some expenses covered for the meetup, and then people will upvote or downvote your proposal. And if they upvote it, you will get some reputation in the Polkadot, and then you will become a member of the Polkadot, and you can vote on future proposals and so on. So this is for the smaller grants, basically. Please join and try to help us forward the ecosystem. We really want to help you, help us, help everybody build a better Web3. And of course, we are looking for one intern in the technical education team. This is a paid position for either a full or part-time student. You will be learning about blockchain in the midst of the action. You will be doing the same thing as a tech ed team. You can find other open positions at this link. So it's either web3.bamboohr.com/jobs or just web3.foundation/jobs. We are also looking for ambassadors in the community. We're looking for translators of our wiki page. We're looking to assist people with grants to work on projects which just help the Polkadot ecosystem, in particular the Polkadot that I mentioned. So please join us and contribute to growing the Web3 ecosystem. Feel free to get in touch for anything at all, any reason at all. These are my contact information, or connect with us on Reddit, Twitter, wherever else. We are ready to help you get on board with Web3 and Polkadot ecosystem. Thank you very much for your attention. I hope that I'm going to be joining you in a few minutes and answering your questions. If not, we'll meet another day. Thank you for the invitation and good luck. Enjoy.